Hello, in this video I'm going to solve the following question number 6 from this past paper. Let us read the question together first. The first three terms of an arithmetic progression are p squared over 6, 2p minus 6, and p. Part A. Given that the common difference of the progression is not 0, find the value of p. If done completely, this brings you 3 points. Part B. Using this value, find the sum to infinity of the geometric progression with the first two terms, p squared over 6 and 2p minus 6. If done correctly, this will bring you 2 points. That would be a good idea if you pause the video at this point and try to solve the problem yourself first. If you do your calculations correctly, the answers for parts A and B are as follows. In part A, you will realize that P is 12. And in part B, you will see that S, the sum to infinity, is 96. Okay, now let us try to solve this problem together. In part A, I know that these are three first terms of an arithmetic progression, and let us say that the common difference is D, and we know that the common difference is not 0. So if I ask you, what is the common difference D? You can write it in two different ways. You can say that this term minus that term. Okay. You can also write this term minus that term, which if I open the pair of brackets, so this becomes minus 2p, p is minus p, and then this becomes plus 6. So I would write it as plus 6 minus p. So on the one hand, the common difference is this. On the other hand, the common difference is that. So they have to match. So it means that what I do, I would say that 6 minus p is equal to 2p minus 6 minus p squared over 6. And this is just a simple equation, a quadratic equation in p, so I solve it and find p. So in order to solve this, I prefer to multiply everything by 6 to get rid of this fraction. So this becomes 36 minus 6p, and then I will have 12p, yes, minus 36, and then I have minus p squared. I move everything to the left to make my quadratic equation. So minus p squared becomes p squared when moved to the left. And then I have 12p, move to the left, minus 12p, minus 6p is minus 18p. And then what I do, I also move minus 36 to the left. It becomes plus 72 equals to 0. Okay, you can use ABC formula to solve this. But because the numbers are easy to guess, so let us just do the guessing, yes? I ask myself, can I find two numbers whose sum is minus 18 and the product is 72? Yes, the answer is simple. One of them is minus 6, the other one is minus 12. So what I do, I use factorization to solve this equation. So I open two pairs of brackets, p here, p there, and then those numbers that I just guessed was one of them minus 6 and the other one is minus 12, yes? The sum of these two numbers is indeed minus 18. The product of these two numbers is indeed 72, okay? Otherwise, you can use probably the calculator in this exam and to find this using the ABC formula. So I was able to do it in that way, so I prefer to do it in this way. So then I would say that either this one is 0 or the other one is 0 because the product of two numbers is equal to 0. Either this one is 0 or that one is 0. This one 0 gives me p equals to 6, or this one equals to 0 gives me p equals to 12. But there is a reason that they have mentioned that the d is not 0, because if I ask you what d is this one, and of course this one. And then you immediately realize that p equals to 6 is not acceptable, because if p is 6 and I put it here, d becomes 0, in a violation with my assumption. So this means that this is not acceptable. Okay, so that is the only answer that we have. So as we wanted, p is equal to 12. But for the second problem, the second part of the problem, I assume that now for the same p, these two numbers are the first terms of a geometric progression. Okay, so let me just do that. If p is 12, I put it there. So the first term is 12 to the power of 2 divided by 6. So I can write it as 12 times 12 divided by 6. 12 by 6 is 2, so it becomes 24. And then 2p minus 6 is equal to 2 times 12, which is 24 minus 6. And this is indeed 80. 80. Yes? So now I want to form a geometric progression so that this first term is 24 and the second term is 18. Of course, how should I continue? It is clear. So I need to find the common ratio. So the common ratio, let me show it with R. Usually the standard one is R. So the common ratio of a geometric progression is any term divided by the previous term. So here, 18 over 24, and if I simplify it by 6, it is 3 over 4. So that's the common ratio. But you know that I am assuming that I want to continue this arithmetic progression up to infinity, so I want to see how much will be the sum to the infinity. The sum to the infinity has this formula, and that is S. Sometimes I can equip it with an infinity, saying that this is S infinity. The formula is the first term, so let me denote it by A sub 1, and then divided by 1 minus R. Of course, you know that S infinity makes sense if the common ratio is less than 1, or the absolute value of the common ratio is less than 1, which is indeed the case. So everything is in order, so I calculate. Instead of A1, I put 24, and then I have 1 minus 3/4. So I multiply everything by 4, this becomes 96, this becomes 4, and then this becomes minus 3. But 4 minus 3 is nothing except 1, so 96 divided by 1 is just 96, as is wanted in the problem. So S infinity here is 96. Okay, so I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.